Welcome, ladies and gentlemen, to an extraordinary seminar on the remarkable world of the endocannabinoid system. So, today we have the privilege of diving deep into a very captivating subject, one of my favorite subjects. Today we are here with the esteemed neuroscientist Dr. Adan de Salas Quiroga. And during this session, we will truly embark on an exploration of the endocannabinoid system, unraveling its intricate structure, but also understanding its vital functions and appreciating some of the pivotal roles it plays in maintaining balance within the human body and also in our day-to-day life activities. So my suggestion for you today is get comfortable because it's going to be around 45 to 1 hour. Get your favorite tea and prepare to be enlightened as we delve deep into how the endocannabinoid system influences fundamental processes such as pain perception, mood regulation, immune response. We will also, of course, touch upon what's the latest research and discuss the exciting potential for therapeutic applications. We, as Cannabiscientia, are honored to have the generous support of our event sponsor, SOMAÍ. As a pioneering European biotech company, is SOMAÍ specializing in the development and manufacture of pharmaceutical products based on cannabinoids. And SOMAÍ is at the forefront of innovation in the European and global medical cannabis markets. So their extensive range of plant-derived medical cannabis formulation aims to provide doctors with a comprehensive spectrum of products with the intention of becoming a dominant brand trusted by both healthcare professionals but also patients in the relevant markets. The ongoing collaboration between Cannabiscientia and SOMAI allow us to commit to advancing medical cannabis education, particularly through our joint effort in providing educational activities for healthcare professionals. So our collective mission between these two entities is truly to increase patient access to medical cannabis by equipping physicians worldwide with the knowledge and the understanding that they need to incorporate cannabinoid therapies into their practice. As you know, because surely if you're here, you're a little bit familiar with Cannabiscientia. Cannabiscientia is an organization that is dedicated to being the leading scientific hub on cannabinoid therapies and education on these therapies and the physiological system on which these therapies are working. We connect research, train healthcare professionals, and patients, and aim to accelerate the understanding and the adoption of cannabinoid therapies at both clinical but also academic levels worldwide. And our STEAM Science Committee at Cannabiscientia is comprising of renowned medical professionals, veterinarians, associate professors from esteemed medical faculties across Europe. I spent many years focusing on medical cannabis education, and their expertise actually spans subjects such as cannabis plant, but also, as today, the endocannabinoid system, and the effective use of this cannabinoid medicine in treating various pathologies. And what for me it's really important, of course, is that not only there is their passion and their knowledge, but also this is coupled with practical experience in working with it. And today, Adan, which is one of those members, will lay the groundwork for comprehending really the fascinating world of the endocannabinoid system and its profound significance for overall health and well-being. So, after this very long monologue, let us embark on this enlightening journey together as we strive to bridge the gap between the scientific knowledge and practical application in the field of medical cannabis. Thank you, and let the seminar begin with a word from our partner, George Bello, which is the Chief Operating Officer at SOMAI Pharmaceuticals.
Hi, Viola. Thank you so much. SOMAI is a very proud sponsor, I would say, in any research or information that helps to get more information about the endocannabinoid system. It's always hard to pronounce. And in general, anything regarding cannabis helping out the process. What I want to say is that, we are located in Lisbon, Portugal. We're a manufacturing pharmaceutical formulations facility. The company invests in extraction, we invest in research and development, and we research in many new products, such as you can see SOMAÍ capsules or patches and new formulations and new products that will soon be coming to the market. So we're very proud to be the sponsor of this, and we hope this will be a very entertaining and positive information for us all to learn a bit.
Thanks a lot, George. And I think everyone is keen to hear it from Adan. So I'll pass over the word onto him. Just a sec. There we go.
Okay, so thank you, Viola, and people from Cannabiscientia, and also people from SOMAÍ to make this possible. So let's jump into the presentation. You should be watching my presentation right now. Viola, is everything okay? I understand it is, but I'm gonna continue. So, as Viola said, we are gonna talk about the discovery of the endocannabinoid system. No, we are gonna understand and go all through this fascinating system. So, I like to start introducing. I mean, we are gonna talk about the endocannabinoid system. First, we need to present the plant. The plant, the scientific and Latin name is Cannabis sativa, but it has many names. It is known as cannabis, marijuana, hemp, weed, and that depends on the culture and language. Well, this is a fascinating plant that it's been for millennia with human beings, and we can take advantage of every part of it. So even the roots, the chives and fiber from the stem, but also the seeds. And in this case, we are gonna focus on the flowers because the flowers are very enriched, especially those in the female plant, are very enriched in compounds, chemical compounds with potential biological activity. So to date, it's been more than 560 different chemical compounds are isolated and identified from cannabis. And we can distinguish three main groups. The first one would be the flavonoids, which are responsible for the flavor of the plant. Then we have the terpenes and terpenoids, which are aromatic compounds responsible for the smell and aroma, but they also exert very interesting and promising therapeutic potential. And then there is a last group that in their chemical nature, they are terpenophenols, and they are called cannabinoids. And those are very like very interesting and the focus today. No, so to date, 125 phytocannabinoids, because they have this vegetal origin from the plant, have been isolated from Cannabis sativa. But there are two, which are the most important or remarkable, given their pharmacological and abundance properties. No? So the first one is the delta-9 tetrahydrocannabinol, or abbreviated THC, and the other one is cannabidiol, or CBD. So this is also to let you know that, I mean, Cannabis sativa is the only plant that actually produces these compounds of this structure called as cannabinoids, but there are other plants such as those from the Radula genus or Helichrysum or Rhododendron that produce molecules with a different structure but which are called cannabimimetic. That means they can also interact with the endocannabinoid system. So this is also something that I like to show, because it is important to get a perspective of what we're talking about. No? So this is the history of cannabis and its relationship with humans. So first, robust evidences of the cannabis cultivation from humans date back 10,000 years before our current era. So about 12,000 years ago. And these are archaeological rests from the Jomon time in Japan. There are other archaeological fragments that could be depending on they could be derived from hemp imprints in clay found in the Czech Republic, dated 25,000 years ago. I mean, that is by far, if that is confirmed, by far the oldest record of cannabis use by humans. And then in the medical aspect, almost 5,000 years ago, we know that cannabis was part of the Chinese pharmacopoeia. There are also extensive references in various Egyptian papyri that describe with very detail how to proceed, how to prepare cannabis, and for which maladies or pathologies it could be used. No, but also in the Atharva Veda in India, in both the Aramaic and Hebrew versions of the Old Testament, in which they mention cannabism, which is something like aromatic cane, and it is believed to be the etymological origin of the word cannabis. No. Then also very famous physicians like the Greek physicians Pliny the Old or Dioscorides or the Galen, which was from Rome, no, but also Avicenna from Middle East. And then the modern history of cannabis started with Dr. Sir William O'Shaughnessy, who was the first that applied the scientific method to the study of the cannabis with his seminal paper on the preparations of the Indian hemp or ganja. And then the prohibitionist trend started not even a century ago. So in 1937, in the United States, was published the Marijuana Tax Act. That was the first milestone in a prohibitionism trend, no? That was followed by the Single Convention on Narcotic Drugs from the 1961, and then again in the 71. So, but we all, and our fathers, and probably our grandfathers, have been born during this century. But it's interesting to take perspective, 1 century against at least 12,000 years of human relationship with this plant. So, coming back to the issue that today, we know that there are cannabinoids such as THC that are able to selectively interact and activate receptors that are expressed or present in most cells of our body. This would be a process analog to a molecular key getting inside the keyhole of a lock and being able to open the lock. That would mean sending some information to the inner of the cell. So this, actually, I mean, we humans, we didn't develop these receptors to sense signals coming from a plant. We actually have these receptors because we produce the natural molecular keys for these receptors, which are called the endocannabinoids or endogenous cannabinoids. So there are 2, which are the arachidonyl ethanolamide, AEA, or anandamide. So anandamide comes from the Sanskrit and means bliss, joy. And so it would be something like the amide of joy. And then we have the other one, which is called the 2-arachidonyl glycerol, or 2AG abbreviated. So this discovery allows us to characterize a cell communication system, which is fundamental for human physiology, which is called the endocannabinoid system. And what happens is that the THC, although they have different chemical nature, the THC is somehow mimicking the 3-dimensional placing of certain very important parts of the molecule. And that's why it's like a copy of this molecular key, which we call anandamide. So let's jump into the endocannabinoid system. Well, this is a current and complete representation of the endocannabinoid system. But do not worry, because I placed this just to scare you, because let's make it simple. We have 4 main elements within the endocannabinoid system. So first we have the endocannabinoids, that we already mentioned, no? Anandamide and 2AG. And there are related molecules that also are able to interact with this system. Then we have the receptors. There are two main receptors. The first one is called cannabinoid receptor type 1, abbreviated as CB1, which is the main responsible for the psychotropic effects associated to cannabis. And then we have the other one, which is called CB2, and is more abundant in the periphery, especially in the immune system. And then we have other type of receptors that belong to different chemical natures. Then an essential part of this system are the metabolic enzymes. Those are the enzymes responsible for the biosynthesis of the endocannabinoids, such as these two, and the degradation of endocannabinoids. And why is this important? Because the endocannabinoid system is overall a system of transducing of information, a transmission of information. In order for this information to transmit a coherent message, it must be exquisitely controlled in time and place. And we get to that precisely by controlling the expression of the metabolic enzymes, those that produce the endocannabinoids and shut down the signals. And then we have the modulators that they belong, they are with peptidic nature or lipidic nature, and they upregulate or downregulate the overall activity of the system. Well, this is also to get perspective. So not only humans have endocannabinoid system, not even mammals, the endocannabinoid system, it is believed to be originated in ancient metazoans. So the ancestors of all animals. And as you can see in this graph, sequentially, different elements of the endocannabinoid system have been incorporated sequentially throughout evolution. And there is one, curiosity as that insects, for some reason, insects are the only group of animals that they don't have endocannabinoid system, but their ancestors do. So for some reason, they lost it throughout evolution. Well, now let's talk about homeostasis. What is homeostasis? Homeostasis is a term introduced by Walter Cannon in 1921. And it comes from the Greek words homeo, meaning same, and stasis, or steady. And it could be defined as a set of physiological reactions that keep the internal environment stable against inner and outer factors that are constantly changing. As you can see here, we have stress, trauma, epigenetic factors, the ambient metabolism, nutrition, etc. And it could be something similar to a thermostat. When the conditions change, there are some receptors that sense those changes, and they communicate with an effector and start a reaction that goes in opposite direction to rebalance the system. So this is homeostasis. Obviously, the homeostasis is held at the molecular and cellular level, but also at the level of organ and anatomical systems, establishing very convoluted hierarchical relationships among the different anatomical systems. But there are three anatomical systems which are particularly important in the control of homeostasis, and those are the endocrine system, the immune, and the nervous systems that communicate with hormones, cytokines, and neurotransmitters, respectively. And even between these three, we can distinguish one above all the others that is particularly important in controlling homeostasis and our physiology. And that could be the nervous system, and like the power ring, or the ring of power, one to control all of them. And I don't know if you read the books or are familiar with the films of the Lord of the Rings, but if you are, you know that behind the ring of power, there is also Sauron that is somehow controlling the ring of power. So, I mean, let's take out all the negative connotations, but in this case, we could be talking about the endocannabinoid system, the one that is behind the nervous system and therefore controlling all the others. But in addition, we know that the endocannabinoid system is present in every organ and anatomical system, directly controlling its own function. So let's dive a little bit more. So, as I was saying, every organ and anatomical system express the endocannabinoid system where it controls essential functions. For instance, we have within the nervous system the motor coordination, pain, nausea, appetite, sleep, memory. Within the skin, the sensory perception, cell proliferation, the sperm motility, oocyte maturation, the bone turnover, blood pressure, the stress response, energy metabolism, immunomodulation. There are many, many. And we are going to go a little bit in detail in some of them. We don't have time enough to go all through, but we can say, as I was saying, that the endocannabinoid system is somehow safeguarding the process of homeostasis. It is one of the main physiological responsibles for that. And having a pharmacological tools such as phytocannabinoids that are able to interact with this system to ensure homeostasis is really a unique biomedical opportunity. So if we talk about the endocannabinoids action, we can distinguish two different ones. The first one is local. That would be either autocrine or paracrine. What that means? Autocrine would be that the same cell that is producing and releasing the endocannabinoids is going to receive the signals in their own receptors. Then we have the paracrine mechanism, which is an adjacent, a closed cell that releases the endocannabinoids that are going to act in the adjacent cell. And then we have a distal action of cannabinoids. That means they go into blood systemic circulation, and certain stimuli such as stress, food presentation, inflammation, or injury, they trigger an on-demand production of endocannabinoids that are released into our blood circulation, and they go to distant targets where they can control mood, reduce anxiety, lead to analgesia, or increase food consumption. So, as you see in these drawings, I mean, the endocannabinoid system is controlling and is somehow playing a role in every single action that we do every day. But there is a very famous sentence from Vincenzo Di Marzo, which is a famous researcher on the cannabis field, who said in the 1998, trying to explain what are the functions of the endocannabinoid system, he said, look, the endocannabinoid system helps us to relax, eat, sleep, forget, and protect. So let's use this as an axis to guide us all through the presentation. This is perhaps one of the most important homeostatic processes controlled by the endocannabinoid system. Is what we can call the homeostasis of neurotransmission. And why is that so important? Because this is very upstream in the control of other system and physiological reactions. So here we have depicted a synapse. What is a synapse? A synapse is a chemical communication between two neurons. So above we have the presynaptic neuron, that is the one that through an electric impulse sends an information. That is when the action potential, that is this electric stimulus reach, it releases the neurotransmitter to the synaptic cleft. This neurotransmitter is going to act upon some receptors present in the postsynaptic neuron that lead to a cell response. Well, there are many situations, both in physiological and pathological conditions, in which this neurotransmitter release gets somehow out of control. That leads to the activation of a different type of receptors and obviously a different type of cell response that could be pathological. So this should be, this is an imbalance and this should be somehow rebalanced. Then what it happens is that the endocannabinoids are produced on demand upon this stimulus on the postsynapse. They migrate, they travel to the presynapse where they activate cannabinoid receptors, and through different mechanisms, they converge on a inhibition of the release of the neurotransmitter, and therefore coming back to an equilibrium. Well, this is important because, as I was saying, is very upstream in many of the functions controlled by the endocannabinoid system. And it's also important to know that this is the neurobiological substrate responsible for the psychotropic effects of THC or cannabis, because it's precisely interacting upon this process. So, first of all, let's start with relax. Here we're going to talk about stress regulation, control of involuntary movements, pain modulation, and pleasure, joy, and reward. So, if we talk about stress, obviously stress involves many different organs, but there is a structure which is essential in stress regulation, that is what we call HPA axis. That is the hypothalamus pituitary adrenal axis. The hypothalamus and the pituitary gland are both structures within the brain, and then they communicate chemically through hormones with the adrenal cortex that produces cortisol and other glucocorticoids, which are the effectors of stress. So, we know that the endocannabinoid system is present in every single step of this chain. So let's see how is this homeostatic process. So we have a first or rapid response that converges. So when we start these stress signals, there is an activation of the enzyme Fa, that is fatty acid aminohydrolase, and is the enzyme responsible for degrading, for the breakdown of anandamide. Therefore, if we activate this enzyme, what we have consequently is a decrease in the levels of anandamide, and this is one trigger of the stress response that involves certain physiological reactions. And one of those is the production, as I was saying, of glucocorticoids, such as cortisol. Well, it is well described that cortisol acting upon certain neuronal circuits leads to an increase on the levels of 2-AG that, let's remember, is the other endocannabinoid, what somehow terminates the stress response and again coming back to an equilibrium. So the process of control of involuntary movements is very directly depending on the homeostatic control of the neurotransmission that we just explained. And this has therefore many therapeutical utilities, such as in the syndrome of Gilles de la Tourette, that is a syndrome in which patients have a lot of tics and uncontrolled movements, spasms, and that is why cannabinoids have proven to be so useful in the context of this disease. It happens something similar in different types of dystonia, which also occurs with involuntary movements, as well as with the spasticity associated to a neurodegenerative disease such as multiple sclerosis. Actually, it is interesting. In Europe, there is an approved pharmaceutical drug, which is called Sativex, that is precisely prescribed for treating the spasticity associated to multiple sclerosis. Let's talk a little bit about pain modulation. So here, what we have depicted is an scheme of the neurobiology of pain. So briefly, we have two pathways. First is the ascending pathway that we call also nociceptive. That is the pathway responsible for transmitting pain from the periphery to the brain through the spinal cord. And then, so that is the one responsible of sending the pain signals. But then we have the other one, which is called the descending pathway. That is a modulatory one, that it starts in the brain and projects to the spinal cord. And what it does is actually inhibits or modulates the signals coming from the ascending pathways. Well, we know that the endocannabinoid system is again present in every single step of these pathways. In some pathological contexts, such as chronic neuropathic pain, we know that there is an overactivation of the ascending pathway and a decrease in the activity of the descending one. And that is why, for instance, using cannabinoids through different mechanisms which are complex, and I mean, there's no point to get into detail today, but they converge in the opposite effect. So they decrease the activity of the nociceptive pathway, we remind is the one that transmit pain signals, and increase the activity of the modulatory one. So eventually what we have is an analgesic response and pain modulation. And this is quite interesting. It's the case of Jo Cameron. So Jo Cameron is a Scottish woman that has two mutations in the Fa gene. Remember, Fa is the enzyme responsible for degrading anandamide. So what it happens is that Jo Cameron has a hypofunctional enzyme. That means it is somehow silenced. It doesn't work. It's dysfunctional. Therefore, what it happens with Jo Cameron is that she has double of levels of anandamide than the general population. And curiously, Cameron suffered broken bones, cuts, burns, surgeries, and childbirth with no need of using analgesics. So that is a quite interesting reflection of the importance of the endocannabinoid system. Now let's see a little bit about pleasure, joy, and reward that we all like. So perhaps you heard about this so-called runner's high. That is the feeling of relax and euphoria that follows a session of a strong exercise. Well, as you can see here, exercise leads to an increased levels of anandamide in blood and also increased feelings of euphoria. Well, traditionally, it was believed that this mechanism was dependent on endorphins, which are opioid peptides. But as you can see here, naltrexone is an inhibitor, a blocker of opioid receptors, and we still have this euphoric response. So nowadays, it is believed that anandamide and endocannabinoids are one of the most important mediators in this runner's high response. But also, it's been demonstrated that we produce endocannabinoids and are mediators of our feelings of joy after singing, after hedonic eating, and after certain sexual practices such as orgasm, masturbation, and certain BDSM interactions. Hence, it is not surprising that genetic variations of different elements of the endocannabinoid system are either associated with happiness, but also other genetic variability is associated with increased incidence of depression or bipolar disorder, as well as eating disorders such as anorexia nervosa and bulimia nervosa. So overall, we can see that the endocannabinoid system plays a crucial role in mood homeostasis. Well, as we were saying and explained, do you remember this homeostasis of neurotransmission, depending on the endocannabinoid system? So the endocannabinoids activate CB1 cannabinoid receptors, and they lead to a decrease in the release of neurotransmitter, right? Well, this is true for most neurotransmitters, such as glutamate, GABA, serotonin, acetylcholine, or noradrenaline. But one very notable exception. So when we activate CB1 receptors, that lead to an increase in the release of dopamine in the VTA, which is the ventral tegmental area. This is the source of what we call the mesolimbic pathway or the reward pathway, which is essential in the positive feedback associated to pleasure and joy and all these mechanisms that we were talking before. Now let's talk about eat. Here, we'll present appetite, food intake, and energy metabolism. But all these three mechanisms are really, really complex. And as you know, they involve many different organs and anatomical systems. So let's just go briefly through some of them. So within the brain, activating the endocannabinoid system is controlling food intake, but also the motivation for palatable food, as well as the hedonic properties of food. In the nose, we know it is controlling odor sensitivity and therefore the food-seeking behavior. It also controls the neural responses to sweet taste in the mouth, the fat preference in the gastrointestinal tract, and the secretion of ghrelin. Ghrelin is the main orexigenic hormone. That is the main hormone that is promoting us to eat and to feed. Then in the pancreas, we know is essential or is controlling insulin secretion. In the liver is controlling the process of lipogenesis, which is the creation of lipids essential for producing triglycerides and fat. Then it controls the glucose uptake within the muscle and the process of adipogenesis, that is fat production, which is also very important. So, as you see, collectively, all these processes are somehow increasing energy reserves. So, one could wonder, is somehow the endocannabinoid signal system promoting obesity? Well, there is a very interesting and very recent hypothesis that it's been proposed, and is that the CB1 receptor could be a cornerstone of exostasis. What is exostasis? So, a very controlled mechanism, such as food intake or feeding, which is essential for living, must be regulated. And we could distinguish two types of regulation. So first, we could have endostasis. That is, I eat when I'm hungry. We have here the Homo endostaticus to the right, no? That responds obviously to inner signals from the individual. That is, if we have low levels of glucose in blood, that would trigger our desire for eating, no? But then we have the other one, that is the exostatic mechanism. I eat every time I see food. And then this one is more depending on external signals, such as food presentation, the hedonic component of food, and obviously the others. And as you can see in this Homo exostaticus, it allows us to accumulate energy reserves. So here we all believe, or it looks like Homo endostaticus is more fit to the environment. But what happens if the conditions change and they are poorer? That perhaps the Homo endostaticus couldn't be able to survive, while the Homo exostaticus that had energy reserves is able to survive, and that's why that could be somehow acquired throughout evolution. What happens nowadays? That again, conditions change, and now we have constantly stimulus of food presentation all over, and it could be that this exostasis mechanism wouldn't be so adaptive as it was before. Therefore, it's not surprising that a pharmaceutical company known as Sanofi Aventis, they developed at the beginning of this century a drug called rimonabant, which is a blocker, an inhibitor of the CB1 cannabinoid receptor. And it was obviously aimed to weight loss. And it worked nicely, actually. People lost weight, but there was a significantly increased risk of psychiatric adverse events, such as depression, anxiety, and even risk of suicide. That's why it was removed from the market. And subjects, as I was saying, treated with rimonabant, that we remember is a CB1 inhibitor, lost weight very efficiently, but they also lost the will to live. That is again pointing to the crucial role of mood homeostasis played by the endocannabinoid system. Sleep. Here we're going to talk about circadian rhythms, body temperature, and sleep architecture. So when we talk about sleep, again, this is a highly regulated process, and we have different factors such as autonomic function, immune status, energy demands, potential offspring needs, decision, circadian phases, the sleep history, emotional status, etc., and disease. And they all converge in the regulation of the activation of a type of neurons that we call orexin-hypocretin neurons. And to summarize, if these neurons are active, that means they are firing, then we are awake. But if these neurons get off, let's say, then is when we enter into sleep. And as we see here, in addition to, the endocannabinoid system control different factors that are controlling the activity of the orexin neurons, but also, as you see in the drawing to the right, the orexin neurons that precisely release orexin as their neurotransmitter produce endocannabinoids that are going to act upon adjacent cells. So there is an indirect connection of the orexin neurons to the overall circuit. So, as we can see here, and these are data coming from humans, there are rhythmic patterns in the release, in the amount of endocannabinoids that we have in circulation in our blood. And as we can see here, there are opposite effects or opposite patterns in the two endocannabinoids. So 2-AG is mainly released during daytime, and while anandamide is mainly released during nighttime. And as you can see here, humans that were sleep deprived, they lost this pattern of rhythmicity of anandamide levels. Again, body temperature. We know that body temperature follow also circadian rhythms, and as you can see in the figure to the left, temperature means are higher during daytime and they decrease during nighttime. And this is quite dependent on the regulation of the endocannabinoid system. And as we see here, high doses of THC can induce strong hypothermia in animal models. Now, sleep stability. What do we have here? Here we have, this is coming from animal models, but this in black is the electroencephalogram, and in red we have electromyogram. These are reflecting or a representation of the brain activity and the muscular activity. And with these two together, we can very nicely discriminate or decide when we are in a waking phase or when we are in a slow wave sleep cycle or rapid eyes movement phase of the sleep. And as you can see here, we can represent this in different colors. Well, in animals that receive this molecule AM281, which is an inhibitor, a blocker of CB1 cannabinoid receptors, so they lack the activity of the endocannabinoid system. As you can see here, we first of all totally lost the slots of the REM sleep, and again the slow wave sleep is completely fragmented, so it is affecting sleep stability. Now, let's talk about forget. And here we are gonna go briefly through deletion of aversive memories and a little bit of memory and learning. Well, this is interesting. This is coming from the seminal paper that demonstrate that the endogenous cannabinoid system is controlling the extinction or the deletion of aversive memories. What do we have here to the right? In this graph, this is a very classic conditioning protocol with animals, again, with rats, in which the animals are conditioned to a certain sound stimulus, like a tone, and then they receive an electric shock. And at some point, the animals, every time they listen the sound, they react because they know it is somehow associated to a negative stimulus, such an electric shock, and then they show fear responses. And that in a mouse or in a rat is just freezing. They get completely freeze. What happens is that if we start giving the stimulus, the tone, but without the electric shock, then the animals somehow learn and forget the aversive memory that was associated to this tone, and then the time they spend frozen, as you can see here in the white circles, decrease. That means they start acting normally even when they listen the tone. Well, what happens when we don't have the CB1 cannabinoid receptors? That the mouse or the rats, they don't have this adaptation. They keep spending the same time frozen. They cannot delete, they cannot forget this aversive memory. So this is pointing like the role of the endocannabinoid system in trauma homeostasis. Well, this in a possible translation to humans is what we call post-traumatic stress disorder, or PTSD, and is when these mechanisms that should delete aversive memories fail for some reasons, and then we got stuck into trauma. Therefore, it is not surprising that people with PTSD have lower levels of circulating endocannabinoids, and also that really cannabis-based treatments are highly effective and very promising as treatment for PTSD. Well, memory and learning are very complex processes and essential also for living, and they are a bit too deep to go through all of them today, but what I want to show is that the endocannabinoid system is essential for memory consolidation and retrieval of these memories, and therefore allowing learning. And last, let's talk about protection. And here we're gonna go through control of hyperexcitability, neuroprotection. Let's see what happens with the CB2 cannabinoid receptors that we barely talked today, and self-fate. Well, there are certain insults to the central nervous system, such as epilepsy, stroke, neuroinflammation, hypoxia, ischemia, neurodegeneration, and exposure to large doses and sustained exposure to excitotoxic drugs, and collectively these lead to brain damage. Well, we know that the endocannabinoid system, thanks to its anti-inflammatory, anti-excitatory, antioxidant, neuroprotective, and pro-survival properties, acting upon neural progenitors, neurons, and glia, and interacting with other systems, is able to increase the process of neurogenesis and gliogenesis, that is the newborn neurons and newborn glial cells, which are let's say the bricks, the elements that conform the neuron, the brain. They control and increase and favor neuronal and glial maturation and survival, the process of remyelination and the homeostasis of neurotransmission that we already mentioned, and collectively they neuroprotect and repair if there was some damage. So what is hyperexcitability? So the best example is what we call epilepsy. There are many types of epilepsy, but what it happens in epileptic patients is that there is an uncontrolled activity and groups of neurons start firing completely out of control, and this, as I was saying, leads to brain damage. So as we see here, these are animal models of epilepsy, and when we have correct function of CB1 receptors, we have seizures, but very little. And if we block, we inhibit the activity of these receptors, as you can see here, there is a striking increase in the number and duration of these seizures. So we can say that the endocannabinoid system is a circuit breaker in neurological diseases. And what is neuroprotection? Well, basically, neuroprotection is controlling neuron survival. And we know, and it's well characterized, that there are different mechanisms involved in this. And this makes sense in many pathological contexts, such as stroke, for instance, or neurodegenerative diseases, such as Huntington disease, Alzheimer, or Parkinson disease, in which neurons are dying for different reasons. So the endocannabinoid system is helping to these neurons in fighting against neurodegeneration. And now the CB2 cannabinoid receptors. So they are somehow a shield against damage and pathology. So CB2 cannabinoid receptors in physiological conditions are mostly expressed within the immune system. So in the rest of the organs are expressed in very low amounts. But what happened that in virtually all pathologies in which it has been studied, there is an increase in the levels and activity of CB2 cannabinoid receptors. And it has also been described that activations of these receptors are associated to overall protective effects. So it is a quite interesting molecular target, and there are many research groups and pharmaceutical companies trying to develop pharmaceutical tools that target this receptor because the potential for the therapeutic potential is really huge. And last, we are talk briefly about cell fate. What is this about cell fate? Well, this actually gathers a lot of concepts, but there is a process which is called apoptosis, that is programmed cell death. And we know that the endocannabinoid system is controlling this process in which the cells can, for certain reasons, undergo in this programmed cell death. It could be through apoptosis or what we call autophagy, that is the cell self-digest. And of course, these two processes are quite interesting in the case of cancer, because tumors are cells that are proliferating out of control, and being or having a molecular mechanism that could lead to these cells to undergo apoptosis or autophagy is quite interesting and highly studied in research labs. But then also another aspect of cell fate is the development, in which we have stem cells, progenitors, that are dividing and are creating our entire body. So we know, and this is quite extensive topic, embryonic development. And it was actually my specialty and I love it, but I mean, we need an entire talk only to discuss about this. But we know that the endocannabinoid system is present and is controlling sequential steps throughout embryonic development, from fertilization, implantation, the proliferation of neural progenitors, the cell fate commitment of these neurons, the migration, the morphogenesis of these neurons, and also in the adult brain is controlling the what is called postnatal neurogenesis, or the birth of new neurons in adults. So let's conclude. Throughout our today, we learned that cannabinoids modulate the activity of the endocannabinoid system overall. We learned that the endocannabinoid system is an endogenous cell communication system present in most animals, and that is located in every single organ and anatomical system, where it controls key aspects of most physiological and pathological processes. And overall, is a system that is targeting the process of homeostasis, is ensuring, is a safeguard of homeostasis. We also saw that a dysfunction of the endocannabinoid system may be involved in the origin of different pathologies, and that the endocannabinoid system adapt its levels and function, trying to adapt and counteract most pathological processes. Therefore, the endocannabinoid system is a unique therapeutic target, and cannabinoids are very promising and potentially disruptive biomedical tools. So it's been everything, and thank you all for your attention, and Cannabiscientia for inviting me to this talk. And well, let's try to, if you have some questions.
Adan, that was amazing. You can leave. I would maybe keep your slides because I already
Okay.
see. Thank you. Really amazing. Um, I know I got a lot, so I'm sure everyone actually got a lot today. As you drink up a little bit, because you almost talked for an hour, but it just flew by, I wanted to send on screen. I really liked how you defined the CB2 being a shield, actually. And so we got okay, don't run away. We got a question from Sasha regarding CB2 and the role. Actually, do we need to have an agonistic activity on CB2 to try and like work towards neurodegenerative disorders? And there was a little debate here whether that was better or better to work through other targets. So you see here, there was another question that was saying,
Yeah, I believe that depends on the neurodegenerative disorder, because the mechanisms involved in Huntington disease or in Parkinson are not the same. And also there are certain discrepancies between animal models and human pathology, because it seems that, for instance, immune response seems to be more important in the pathophysiological mechanisms of neurodegenerative diseases in animal models, whereas in humans, it, at least in what it's been done so far, it seems it's not so important. So that depends, but I mean, obviously CB2 is quite important, and especially in controlling immune responses. But there are some I mean, then the pro-neurotrophic action of CB1 is without discussion, as it is the neuroprotective role, because in many neurodegenerative diseases, once one type of neuron is dying, that leads to an unbalance in the excitation of some neuronal networks, and this leads to excitotoxicity that could be somehow counteracted by activating CB1 receptors. So it is interesting, but I mean, having a pharmacological tool such as THC that is able to activate both CB1 and CB2 receptors, I understand it goes with some adverse effects, but yeah, I mean, I wouldn't choose one of
Sure.
I wouldn't go only for CB2. Yeah.
I mean, in this regard, it came to my mind as well a paper from a group of Italians, actually from a few years ago. But again, it was an in vitro study, so we need to, as you said rightly, then kind of like step back to for the translation of that. But on the role, in this case, of CBD on the activation of PPAR, it actually was quite useful for neurogenesis, but also to decrease the levels of amyloid beta, for example. So as you said, it's also pathology specific. And I mean, to be honest with you, while you were talking, I was having ideas for hundreds of other seminars that hyper focused on each of these topics, starting from embryonal development, which is a difficult and very fascinating topic.
It's fascinating. It's fascinating and quite convoluted. Yeah. But
Yes,
and also because there are many diseases, particularly some neuropsychiatric disorders such as autism, epilepsy, that they are believed to be originated during embryonic development, because it's where everything is settled. And of course, I mean, it's fascinating topic, definitely. But we just got a bite into many different aspects of the endocannabinoid system.
totally, totally. Just before we end this session, of course, I'm gonna have here with us to give the final goodbye, also George. And I wanted to remind everyone that this is a series of events. So if you liked today, make sure to not miss out on the 12th of July. We're going to have a seminar dedicated on a sort of 101 on medical cannabis oil. So how to use oils, how to dose them, and how to store them from nonetheless that PharmD, Dr. Marco Ternelli, who's been the leading pharmacist, pioneering pharmacist for cannabis in Italy, with a great wealth of expertise, and also just as Adan, and as you could see today, makes the learning really pleasant to go through. And we all know it's the end of the day and it's through a computer, but there are ways so that a hour can pass through easier. And I think you hit the nail on the head today. So thanks a lot. And also another reminder for you all, because this is coming up way earlier than the 2nd of July, but I'll pass the word directly to George for this.
Sure, thank you. First of all, done a really, really interesting, great lecture. I learned a lot myself, actually, so I appreciate it. And thank you, Viola, for organizing this. So SOMAÍ is excited to open our doors to healthcare industry professionals and to give them an inside look at our facility. And through education and transparency, we feel that that's the most important thing in our industry. So we hope that you can go to our LinkedIn page and sign up. I believe it's July 2nd. Yeah, it's there. So yeah, we invite everyone to sign up and to come visit us and take a look at how we manufacture our products and our facility. It's, like I said, right outside of Lisbon, 25 minutes, and it's right after the ICBC convention. So we hope to see everybody there. Thank you, guys.
Nice. Thank you very much. We won't miss it. And once again, we'll catch up again on one of the seminars on the 12th of July. So if you liked it, make sure to share this, because of course you've seen it live, but you can rewatch this session. So any of your friends that were busy working or in a different time zone, you can send this link and they can enjoy this wonderful class from Dr. Adan de Salas Quiroga. So thanks a lot, everyone, for being here. And we'll catch up very soon with one of the other educational sessions from Cannabiscientia and SOMAÍ. Thank you.
Take care, everyone.
Thank you. Ciao, ciao.